It's so deeply entrenched in your intuition. A projectile always follows a parabolic path. But why? It all makes sense when we break down the motion of the object into its horizontal and vertical components. We're allowed to do this because motion in these directions are independent of each other, meaning what happens in one direction doesn't affect what happens in the other. First, let's assume that there's no air resistance. This will help keep the explanation simple. Then say you launch a ball at a certain angle, giving it a certain speed. We'll call this velocity vector v. V is going to be made up of a horizontal and vertical component, which we'll call Vx and Vy respectively. Let's look at Vx to begin with. Since we've removed air resistance, there's nothing to slow down or speed up the ball in the horizontal direction. In other words, Vx stays constant throughout the flight of the ball. This means that for every extra second the ball is moving, it moves the same distance in the horizontal direction each time. So if in this time interval the ball moved 5 meters to the right, then it would also move 5 meters to the right in this other time interval. The vertical component, Vy, does not stay constant, however. The ball is constantly being pulled by the force of gravity, which causes the ball to accelerate downwards at around 9.8 meters per second squared, or g. This means that each second, Vy is being reduced by the amount g, meaning the ball will eventually start moving downwards. Since the height at which Vy is 0 is the turning point of the direction of the ball, it is also the maximum height the ball will reach. So at each extra time interval before the maximum height, the ball will move a smaller distance upwards than in the previous time interval. And for each time interval after the max height, the ball will move a greater distance downwards than in the previous, until it hits the ground. Putting these two pieces together explains the smooth parabolic curve that the ball follows. But I'm using the word parabolic quite loosely here. How do we know that the ball follows the trajectory of the mathematical object called a parabola? To prove this, we need a bit of simple maths. This is the equation of an object moving with constant acceleration. You'll probably recognize it as one of the 5 Suvat equations if you've ever taken a mechanics class. This one calculates the displacement of an object as a function of time, using the acceleration and initial velocity to pin down the path it takes. And just like before, we'll consider the horizontal and vertical components separately. First, the horizontal. We can find the horizontal component of the initial velocity vector by multiplying the initial velocity by the cosine of the launch angle. We can do this because the velocity vector makes a right-angled triangle with its horizontal and vertical component vectors when put like this. And because we ignored air resistance at the start, the acceleration in the horizontal direction is 0, so we can get rid of that n term, which gives us this as the equation for the horizontal motion. Now for the vertical component. We can find the vertical component of the initial velocity by multiplying it by the sine of the launch angle, similar to how we found the horizontal component earlier. And because of gravity, there is a vertical component of the acceleration vector, which we stated earlier to be negative g because it's pointing downwards. This then gives us this as the equation for the vertical motion. And now we want an equation that relates the two of these and shows the motion of the object in both the x and y directions simultaneously. For simplicity, we'll call Sy y and Sx x. To do this, we sub one equation into the other. For simplicity, we'll sub the x component equation into the y component equation. After some algebra, we're left with this. Y is a function of x. And if you look closely, you'll see that this is exactly what we're looking for. This is in the form of the parabola we defined earlier.